Hey peeps, it's James Buckle here of Engage Pixel with part 2 of my memory buffer tutorial series, and if you're wondering, yes, I'm still really annoyed that they cancelled the expansion, #SaveTheExpanse, damn them all to hell. In part 1 we looked at saving and loading a fixed set of data via memory buffers. If you've missed it, the link is below, or I'll put a little card in the corner. Now we're going to modify the code that we did in video 1, and we're going to put all the data into a list of data sets, and then we're going to loop through that list, and in each iteration reading or writing the data into the memory buffer and storing it all in a single file. Here we have a representation of the buffer stream, which is a continuous queue of bytes. Below it we have the data to be stored. There are 5 sets of data. We're going to write the data in the same way as we did in the previous video, but this time we're going to stick it all inside a loop. On each iteration of the loop, we write data to the buffer in a specific order. On the next iteration of the loop, we then write the second data set in the same order. We continue doing this until the list of data sets is empty and we've written all the data into a continuous stream of bytes. This can then get saved to the hard drive. When we read the data, we simply reverse the process, and in each iteration of the loop we read the data to the same variables in the same order that we wrote it. And in so doing, each time we go through the loop we put everything in the correct place, and should, when we're finished, end up with all the right data in all the right places, and everything should work just fine. So that's what we're going to do in this video. So let's start by going back to the create, and we're going to create a list in which to store each of the maps, and we're going to call that database. So we'll say database equals ds list create. Then I'm going to create some variables to hold the displayed data in, so that we'll just assign the values once and not keep reading from the data structure all the time. So we'll say display name equals, and then just put 2 empty quotes. So this will just initialize as a string, but it won't actually contain anything. Display age equals blip blip. Display month equals blip blip. And display what are we calling it? Time. Let's call it time equals. Now I need to go to the draw event and actually use them. So we'll replace this call to the DS map with display name. We'll replace this call here with display age. This call here gets changed to display month. No, yes. And this one is display time. So now elsewhere we will actually assign all those values, and then we're not, every time we draw, doing a bunch of calls to a data structure. We're also going to remove the F3 and F4 key presses because we don't need those anymore. We're then going to change F1, so now it just simply says save file. Because we're only using one file now, we're also going to remove the argument name, so it just says save file. And on F2 we're going to do load and remove the argument, so now it just says load file. You can ignore these errors, these are just complaining because it's expecting arguments and I haven't updated the script to remove those arguments yet. Now we're going to change the key press space event. So what we're going to do here is we're actually going to create 4 people. But before we do that, we need to make sure we've cleared out any previously existing data. Our database list is going to contain the indices for the data maps that contain our data packets. These are the locations where GML has stored them. This is an important code concept to understand. The list won't actually contain the data maps themselves, it will contain references that point to their locations in memory, or rather within the engine where GML has stored them. This means when we create a new data map, we will overwrite this entry with the location of the new data. Once we've done this, we no longer have the location of the previous data map. If we haven't already deleted it, we will no longer be able to do so. This means that data will occupy a piece of memory until the program stops running. Do this enough, and you fill up your RAM and crash your program. We call this a memory leak. In GML, it happens most often when you're using data structures and particle systems. This means we have to loop through our list and destroy all the old data maps before we can then add some new ones to replace them. So we're going to move this DS map clear, which is where we cleared the map when we were just using a map. Now we're using a list, we need to loop through that list. So we need to say for var d equals 0, d is less than ds list size database. So we're looping through every entry in the database d++, and for each entry in the database, now each entry will be a different data map containing a little packet of data. So we're going to need to destroy that with ds map destroy database, and then we will use the little accessor line there, d. So this is the accessor here for a list is this line, which allows you to use the square brackets and a number to treat a list like a data structure list like it's a normal array. So we're just grabbing each index within the list and destroying whatever map is associated with it, if there is a map associated. If no data has been loaded yet, then ds list size will return 0 and none of that will get executed. And once we've done that, we need to clear the actual list itself with ds list clear database. So now we've ensured that all of the data's empty, that it's anything that was there before we have removed, and we've cleared the memory, and we're okay to continue. So now what we're going to do is do another loop for var p equals 0. P is less than, and we're going to create 4 people. P++. So each time we loop, it creates 4 different people. And we'll go down to the bottom here and we'll close this loop off. And we'll just indent all of that so it's nice and neat. Now at the start of the loop, we're going to create a local variable, call it person, and into this we will create a ds map. So create a new ds map, and then we're going to then replace every instance of file data with person. So now what we're doing, and we add at the end, we will then ds list the that's not ds list add database comma person. So we've now modified this, so it's going to go through this loop 4 times, and on each iteration of the loop it will create a new data map, a new data structure map. It will then add all this data, the same data, into that map, and then assign the map into a slot in the ds list database. So now instead of having a single data map containing the data, we now have a list with 4 maps of data. Now what we need to do is create a step event. So let's go add event step. In here we're going to check for a key press, and then if the key is a number key, we will display the information for that pressed, the entry that corresponds to the key we've pressed. So we'll say if keyboard check pressed equals vk any key, and a close bracket at the end there. Put that between a couple of squiggly brackets. So if any key has been pressed, we want to then check what key it is, and we're going to say var entry equals 0. We just want to initialize a variable that tells us which entry that we want to actually display. We're then going to loop through the keys. So we're going to go for var k equals 0. K is less than 5. Actually, no, we want that to be 1. We want k to equal 1, and then loop until less than 5, because this will return the numbers 1 to 4, which will correspond with person number 1 to 4 ish. And then we go k plus plus. Couple of squiggly brackets. Within this, we then check the if the number key has been pressed. So we go if keyboard check pressed, and now we're going to use a little function called ORD, which will pass the code that corresponds to a supplied string. So we go ORD. However, with an ORD, we now need to supply a string, and the string we're going to use is k. But of course, k is a real, it's a number, so we need to convert it with string, and then we put k inside it, and then we do a couple of squeaky brackets. So what's happened here, if I have the right number of open, 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 close, 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 there we go, 4 ending brackets. What we're doing here is we have the current number of the loop, the current iteration number of the loop. We're converting it to a string. We're passing that string to the ORD function, which converts it to the corresponding character code, and we're supplying that character code to the keyboard check pressed function and asking it if it's been pressed. And if it has been pressed, we're going to make entry equal k minus 1, because it's offset. At the moment we have the data structure, the database list will have entries 0, 1, 2 and 3 corresponding to 4 people. However, I want to make those correspond to the keys 1, 2, 3, 4. This is purely because otherwise I would be pressing key 0, which is on the right hand side of my keyboard, and then keys 1, 2 and 3 on the left, and that means using 2 hands, and I'm lazy, so I'm just going to use 1 hand on my left. So I say k minus 1, make that entry. We then get to here, we're now going to grab the data map, or the data structure map that corresponds to this index from the database by saying var person equals database. We're going to open some square brackets. We're going to use the little vertical line accessor, and we're going to supply it the variable entry. So we've now grabbed the entry index in the database and assigned it to person. So we now need to actually grab that data out of that data map and put it in the display variables that we created earlier. So display name equals ds map find value person comma name. if we copy that and paste it 4 times, and we change this one to, so we have age, then we have month, and then we have, the other one was time. So we go here and we change the keys to correspond in the data map. So then we have name, age, month and time again. However, age was stored as a number, so we need to convert that to a string using the string function. And the same goes for time, making sure we put a curly bracket at the end and then adding strings to the beginning. So now display name, month, age and time should all be grabbed from whichever set of data we have selected by pressing a key. We're now going to need to change saving and loading. So let's change save. There it is. Let's drag load in as well. So the first thing we need to do in save is get rid of the argument and type in here file, because we're now using a single file and storing everything in that file. We create the right buffer in the same way, but we now need to actually loop through each data set and write it. So we're going to say for var p equals 0, p is less than ds list size database p++. And then we go down to the last buffer right and before buffer save, and we pop the other squiggly bracket in. Then we indent all of this. So now what we've done is for each, we're going to loop for as many entries as there are in the database, in our database list, and we're going to write them into the buffer. First we actually need to grab the data packet, so we go var person equals database square bracket vertical line accessor p close square brackets underscore p close square brackets. So now each entry in the database list has been grabbed. On each iteration it grabs whichever data map corresponds to that index. We need to copy underscore person, and everywhere it says file data, replace it. So now what's happening is on each loop it's going through and it's just taking the data one at a time, then moving to the next set of data, putting it in until it's filled the buffer up, or until it gets to the end of the list rather. Once it's done that, we then just save the buffer to the specified file and delete the buffer to make sure that it frees up the memory. Next we need to update our load. Once again we get rid of the argument as we're using a single file, call it file.buff. Now if we already had data loaded, then we want to actually clear this. Now we've already done that once. We did that over here when we pressed the key. We used this little bit of code here to get rid of all the current data maps. So what that means is we can just copy that and put it over here. Except you don't just go copying code around like that. What you do is you create a new script. So we can create a little script here and we can call it clear database. So we'll call it clear database. I'm going to go up here. I'm going to cut that text out of there, type in clear database. Come down here, clear the database. That's not how you spell database and not how you spell the. And we paste that in. So then what we can do, if we go back up to the key press, we've replaced it with clear database, which means when we get to here it executes the same code that was already there, which means that this is effectively doing the same thing, but now when I go to here I can just type in clear database and do it again without having to retype all that code. It also means if I change the database at any point and want to clear the data again, I just go here and rewrite how the data is cleared without having to go back to every point in the code where I actually cleared the data. So now I've done that, after we've read the use buffer load to load the file into our read buffer, we now need to actually do the same loop that we did when we saved the file in the first place. So we say for var p equals 0, p is less than. Now here's a tricky bit, because when we save we know the size of the database, but when we load the database is empty, so we can't do that. We need to know how many entries there are in the actual file. Now in a couple of videos time we'll actually sort out recording that in the header and so forth, but at the moment I want to concentrate on just the looping part, so we're actually just going to manually say less than 4. Normally you would want to actually code it, you wouldn't want to hard code like this and say and specify exactly this number, but for this instance we're gonna be a little bit naughty and just put the 4 in there and then go p++, open squiggly brackets, and we want to go down to there, put the squiggly bracket at the end of the last add there, and then indent them. Now at the top of the loop we need to create the a data map to load everything into, which we're going to call var person equals ds map create, and then we need to go through each of these where it says file data. We just need to replace that, copy and paste and replace that with person. Now we're also, because we're no longer overwriting the contents of a data map but we're dealing with an empty one, we can change this to ds map add. Although I'm fairly sure that replace will actually just create it if it doesn't already exist. I think that's how it works. ds map add won't overwrite data if there is already if the key already exists. ds add won't add the key and replace the data, so you have to use ds replace, but replace will add, I think, add if it doesn't already exist. But either way, change more ds map add it to the data the ds map person that you created. This now gives us our little packet, so we just need to add that to our ds list database. So we go ds list add database comma person. So now we've actually, once we get to this point, we've looped through 4 times and added each set of data into a map, added it to the list. So we've actually repopulated our database. We then need to actually delete this read buffer by saying buffer delete read buffer, because apparently when I did video 1 I forgot to do that. So that's that looping through 4 times, loading it back out. So now if I save it and run it, so here we have it's empty. It doesn't say undefined anymore because we're using the variables that we created with 2 empty double quotes. So if you press space, it will create 4 new people starting with Tim Burke, and if I press the 1, 2 and 3 keys, you can see it accesses from the database the corresponding person. Now if I press F1, it'll save it, and if I click on the reload button, it reloads it. It's now empty. If I press F2, we've loaded our data again. And there we go. So this video showed you how to store multiple packets of data into a single file by looping through it. In the next video, I'm going to change it so we aren't limited to 4 people, and we will be amending the file each time we create a new person. So effectively, it will open the file up, it will go to the end of the last entry, and it will add an entry there each time you add a person in. Okie dokie. So if you click on the little button in the top right, that should take you to the next video.